A-Level Pure 1 Sequences, Arithmetic Progressions. Let's see what we mean by an arithmetic progression. Consider the lists of numbers 5, 8, 11, 14, 17, 20, 23, or another list 21, 17, 13, 9, 5, 1, -3, -7, or even the odd numbers 1, 3, 5, 7, 9, 11, 13, 15, and so on. In each of these lists, it's easy to spot a pattern. The first sequence keeps increasing by 3 as we move along the list. The second list keeps decreasing by 4. And the third list, that's the odd numbers, keeps increasing by 2. These are all examples of what we call arithmetic progressions. Well, let's just introduce some notation. A sequence of numbers is a list of numbers that may have a finite length or may go on forever. There does not need to be any pattern in the numbers. The numbers in the list are called the terms, and we label them T1, T2, T3, and so on. The nth term will be Tn. So T1 is the first term, and so on. Now, an arithmetic progression is a sequence of numbers that increases or decreases by a fixed amount as we move along the list. In other words, the difference between a term and its previous term is constant. Now, in an arithmetic progression, we use the following notation. We call the first term A, and the last term L if the list is finite. We call the common difference D. This is the amount we add to one term to get the next. It can be 0, it can be negative. If the list is finite, we use the capital letter S to stand for the sum of all terms. Otherwise, the sum of the first n terms is written S subscript n. Here are some examples of arithmetic progressions. The sequence 2, 5, 8, 11, 14 is an arithmetic progression. In this case, we see that we add 3 to any term to get the next. So the first term A is equal to 2 and D is equal to 3. In the second example, we've got the sequence 4, 3.1, 2.2, 1.3, 0.4, -0.5, and so on, and it stops at -16.7. Now in this case we can see that we add -0.9 to each term to get the next. So this is an arithmetic progression with A equal to 4, D equal to -0.9, and L, the last term, equal to -16.7. In the third list we have 22, 29, 36, 43, and so on up till 141. In this case we add 7 to each term to get the next, so it is an arithmetic progression with A equal to 22, D equal to 7, and L equal to 141. Now suppose we have an arithmetic progression, often referred to as an AP. We have that the first term, T1, is equal to A. The common difference is D, so the second term, T2, is equal to A plus D. We then just keep on adding D to each term. The third term will be A plus 2D. The fourth term, T4, is equal to A plus 3D. And that carries on. So we can see the nth term will be Tn is equal to A plus n minus 1d. Now this is an important result. The nth term of an arithmetic progression is given by the formula Tn equals A plus n minus 1 times d. Let's look at an example. The third and the 21st terms of an arithmetic progression are 8 and 62 respectively. Find the first term and the common difference. and also find the 45th term. Now in part 1 we're asked to find the first term and the common difference. Well, to solve this we have the third term is equal to 8. So T3, which is A plus 3 minus 1 times D, is equal to 8. We also have the 21st term is equal to 62. So term T21 is equal to A plus 21 minus 1 all times D, and that's equal to 62. So we have A plus 20D is equal to 62, and also A plus 2D is equal to 8. Now if we subtract those, the A's cancel out and we're left with 18D is equal to 54, so dividing by 18, D is equal to 3. Now if we substitute in equation 1, we have A plus 2D is equal to 8 and D is equal to 3. So A plus 6 is equal to 8. In other words, A is equal to 2. So our answer is the first term is 2 and the common difference is 3. Now in part 2 we're asked to find the 45th term. Well, we've got T45 is equal to A plus 45 minus 1 times D. So T45 is equal to 2 plus 44 times 3, which is 134. So the 45th term is 134. Remember our formula for the nth term, and let's have a look at another example. Find the number of terms in the sequence 31, 29.5, 28, and so on down till you get to minus 86. Well, to solve this, we've got D is the difference between the second and the first term. So it's 29.5 take away 31, which gives us D is equal to minus 1.5. Now the last term, Tn, is equal to minus 86. So what we've got is A plus n minus 1 times D equals minus 86. And we know A is 31 and D is minus 1.5. So 31 plus n minus 1 times minus 1.5 is equal to minus 86. Well, if we add 86 to both sides, we get 117 is equal to 1.5 times n minus 1. If we divide both sides by 1.5, we get 117 over 1.5 is equal to n minus 1, which means n minus 1 is 78, or n is 79. So there are 79 terms in the sequence. Let's look at a third example. The sum of the first n terms in an arithmetic progression is given by the formula n squared plus 6n. Find the first term and the common difference. Well, to solve this, we have that Sn is equal to n squared plus 6n. Now, if we just consider S1, S1 is the sum of the first term, so it's just the first term. So S1 is equal to T1, which is equal to 1 squared plus 6 times 1, which is 7. Now S2, the sum of the first two terms, is T1 plus T2, and that's equal to 2 squared plus 6 times 2, which is equal to 16. So we've got T1 plus T2 is 16, and T1 on its own is 7. So if we subtract, we get T2 is equal to 9. Now A is T1, which we know is 7, so A is 7, and D is the difference between T2 and T1, so it's 9 minus 7, which is 2. So our answer is the first term is 7, and the common difference is 2.